Okay, so today's topic will be simple probability. Suppose a trial can have n equally likely results, and suppose that a success can occur in s ways from the n. From these n equally likely results, we have the success in s ways. So the probability of a success will be s over n. Another way of saying this, the probability, let me write, the probability is the number of desired outcomes over the number of all outcomes. The number of all outcomes. So I'm going to explain what outcome is and what is all outcome, what is desired outcomes, okay? I'll explain in this example, the first example. Okay, before we start, if an event cannot happen, or if it is impossible, then we say that the probability is 0. And if an event is certain, if it is going to happen 100%, then we say the probability is 1. All probabilities lie between 0 and 1. And so if your answer is more than 1, then you should check your answer, because the probability cannot be more than 1. It must be between 0 and 1. If it is 0, it is called impossible event. And if it is 1, it is called certain event. To the first example. The numbers 1 to 20 are each written on a card. The 20 cards are mixed together. One card is chosen at random from the pack. So we have a pack, and in this pack we have 20 cards. And on those cards, the numbers 1 to 20 are written, okay? So you can think of cards like 1, 2, 3, and 20. All these cards put into a pack. Find the probability that the number on the card is even. You're going to find that. B, a factor of 24, and C, a prime. Okay? So, let's start with the first one. Or actually, let's start with the number of outcomes. Let me write all outcomes first. All outcomes. So the outcome is the number or whatever we get when we choose a card at random. Okay, here for example, if I choose a card at random, what can I get? I can get 1, I can get 2, I can get 3. So the all outcomes is going to be the numbers from 1 to 20. 1, 2, 3, 4, 5. This is called all possible outcomes, okay? All possible outcomes. I can get one of these numbers, right? So how many outcomes do we have here? What is the number of all possible outcomes?
20.
20, yes. 20 possible outcomes. So out of these 20 possible outcomes, the first we are going to find the probability of getting an even number. So let's start with that. A. So what was the probability? The number of desired outcomes. So let's write the desired outcomes. Let me write the desired outcomes here for A. Desired outcomes. We want the number to be an even number, right? So we are going to write all the even numbers among these possible outcomes. So the even numbers are 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. So we don't continue because we choose our numbers, desired outcomes, from all possible outcomes. So how many desired outcomes do we have here?
10.
10 desired outcomes. So the probability of getting an even number is going to be the number of desired outcomes over the number of all possible outcomes. That's going to be 10 over 20, which is 1 over 2, which is 0.5. So our answer is between 1 and 0, as you see. Okay, so the probability must be between 1 and 0. So let's do B. A factor of 24. We are going to choose at random a card from these cards, and we want that to be a factor of 24. So first thing, we should write the factors of 24. What are the factors of 24? 24 is 1 time 24, 2 times 12, 3 times 8, 4 times 6, 5 times, so it is not an integer, 5 times, so 24 is not divisible by 5. So we can write 24 as 6 times 4, but it is already written, as you see. 6 times 4. 24 is not divisible by 7. Actually, we don't have to continue after this moment because we already written all the factors. 1, 2, 3, 4. These are all the factors of 24, okay? So let me write factors of 24. It is also the desired outcomes, okay? So 1, 2, 3, 4, 6, 8, 12, 24. But we should be careful here. All possible outcomes from 1 to 20. As you see, 24 is not in this set. So we cannot write 24 as a desired outcome. So the desired outcomes will be 1, 2, 3, 4, 6, 8, 12. Not 24, because 24 is not among these numbers. On the cards, we don't have the number 24. It's not a desired outcome. All right, so desired outcomes 1, 2, 3, 4, 6, 8, 12. If you have a question, please ask. Be careful, we don't count 24 because 24 is not among the all possible outcomes. So the probability of getting a factor of 24 is going to be the number of desired outcomes. How many? 1, 2, 3, 4, 5, 6, 7. 7 desired outcomes, okay? 7 over the number of all possible outcomes is 20. So that's going to be 7 over 20. If you have a question, please ask. Let's go to C. A prime number. So from these numbers, we are going to take the prime numbers, and then we are going to find the desired outcomes. Let's write for C, desired outcomes. So 1 is not a prime number, 2 is a prime number, 3, 4 is not a prime number, 5 is a prime number. So what is the prime number? Prime numbers are divisible by 1 and itself, okay? So the positive factors of prime numbers are the number 1 and itself. For example, 2 is divisible by only 1 and 2. 3 is divisible by only 1 and 3. 4 is not a prime number because 4 is divisible by 2. 5 is divisible by only 1 and 5. 6 is not a prime number because 6 is divisible by 2 and 3. So let's write all the prime numbers. 7, 8, 9, 10, 11 is a prime number, 12, 13 is a prime number, 14 is not a prime number, 15, 16, 17 is a prime number, 18 is not a prime number, and 19 is a prime number. We don't write the prime numbers after 20 because all possible outcomes are from 1 to 20. So what is the number of desired outcomes? 1, 2, 3, 4, 5, 6, 7, 8. 8 desired outcomes. So the probability of getting a prime number is going to be 8 over 20. So both numerator and the denominator are divisible by 4. 8 divided by 4 is 2. And 20 divided by 4 is 5, which is also 0.4. This is the probability of getting a prime number from the pack, okay, from our pack. If you have a question, please ask your questions. All right then, let's do second example. So in this case, we have 2 dice. So do you know what that means? Die. You know what this is?
Yes.
So if you're playing Monopoly, you know, you're throwing this die. 1, 2, 3 are written on it. Up to 6. 1, 2, 3. This is called a die. And if you see the word dice, it is the plural form. Okay?
Okay.
All right, so display all the possible outcomes. We have a black die and we have a white die. We have 2 dice. We are going to throw 2 dice and the possible outcomes. Let's find the possible outcomes. So here I'm going to write the numbers on black die. What do we have on the black die? We have 1, 2, 3, 4, 5, and 6. And here I'm going to write the numbers on the white die. The same numbers. We have 1, 2, 3, 4, 5, 6. Okay? So let me write here the numbers on the black die. Yes.
Could you please repeat it again because your sound wasn't clear in the beginning? Like,
Right,
why did you write these numbers?
Yes, we have 2 dice, as you see, black die and white die. I'm going to write the numbers on the black die here. 1, 2, 3, 4, 5, 6. Numbers on black die. And I'm going to write the numbers on white die here, okay? These are the numbers on white die. So now I'm going to get all possible outcomes. So I am throwing 2 dice. So for example, I can get 1 and 1, 1 and 2, 1 and 3, 1 and 4, and also I can get 2 and 1. So until I can get 6 and 6, for example, I can get 5 and 6, okay? So I'm going to make a diagram for it. So this is going to be the diagram. Let me put these lines. Are you still with me?
Yeah. Yes.
Okay. So these are all the possible outcomes. For example, I can get 1 and 1, as you see. I can get 1 and 2. For example, I can get 3 and 3, right? I can get 3 and 5. And also I can get 6 and 6. These are all possible outcomes. So if I write all possible outcomes, how many possible outcomes do I have?
36.
36. Yes, if you just count all these possible outcomes, 36. So 1 and 1, 1 and 2. I'm not going to write all, I'll get 6 and 6. Totally, I have 36 possible outcomes. Okay, so let's try to solve the questions. The first one, A total of 5. So I'm going to add the numbers on the dice and I'll get 5. How is that possible? So I'm going to circle when I have a total of 5, okay? So here it is 1 plus 1, which is 2. It is not 5. Here 2 and 1. 2 plus 1 is 3. It is not 5. Here we have 3 and 1. 3 plus 1 is 4. It is not 5. So this is a total of 5, right? 4 plus 1 is 5. 5 plus 1 is 6. So we don't include this. 6 plus 1 is 7. We don't include this. And let's look at this. 1 and 2. The total is not 5. So the total will be 5 when we have 3 and 2, right? I'm going to circle that. The total will be 5 when we have 2 and 3. And what else?
1 and 4.
1 and 4. Anything else? Thank you. Anything else?
No.
We don't have, except these, we don't have anything else except these. So how many desired outcomes do we have? So let's write the desired outcomes here. So you can tell me the number. So 4 and 1, 3 and 2, 2 and 3, 1 and 4. Here, the first number is the number on the black die, and the second number is the number on the white die. Black, white, black, white, black, white. So we have how many?
4.
4 desired outcomes. 4 desired outcomes. Okay, so the probability of getting a total of 5 is going to be the number of desired outcomes, which is 4, over the number of all outcomes, which is 36. Divide both the numerator and the denominator by 4. So 1 over 9 is going to be the answer. Any question? So that's going to be 1 over 9. Let's look at the question B now. If you have a question, please ask. So a total of 11. How can I get the total of 11? 1 plus 10 is 11, but we don't have 10 here. 2 plus 9 is 11, but we don't have 9 here. 3 plus 8, so we don't have 8, so 4. So 5 plus 6 is 11. So I'm going to cross when the total is 11. So 5 plus 6 is 11, and also 6 plus 5 is 11, right? What is the number of desired outcomes for this question?
2.
2. What is the number of all possible outcomes?
36.
36. So 2 over 36, which is 1 over 18, is the answer for B. The number of desired outcomes over the number of all outcomes. Any question? And let's look at C. A 2 on the black die and a 6 on the white die. So let me use another color for this desired outcome. We want a 2 on the black die. So we have only 1 2 on the black die, right? And we want a 6 on the white die. And we have only 1 6 on the white die. So 2 and 6. We want to get 2 and 6. This is what we want to get. A 2 on the black and a 6 on the white die. So what is the number of desired outcomes here?
1.
Only 1. Okay, only 1. So 1 over, what is the number of all possible outcomes?
36.
36. So the answer is going to be 1 over 36 for this question. 1 over 9, 1 over 18, and 1 over 36.